Alright, welcome back. This is a video on understanding light pollution and a review of the SQM reader from Unihedron. I've owned this little SQM reader for about 5 years now, and I've used it in a ton of places to see just how dark it is when I'm actually out in the field. Right around when I first got it, I took a bunch of readings while on my way back from imaging out in the Pawnee grasslands. I want to see how its readings compare with the World Atlas 2015 map from lightpollutionmap.info. But before we begin, I want to mention that readings may be slightly different due to light pollution in the map being measured from ground brightness rather than total sky glow, which includes light from stars in the Milky Way. With that in mind, let's begin. So right off the bat, I'm going to take some of these coordinates that I've already jotted down. Alright, so here is our first point. And right off the bat, we are seeing quite a difference of half a magnitude. So I'm going to go ahead and start another column here, and we're going to compare how they are. So this one is saying 21.56, 21.14, 20.98. Now keep in mind we are looking at data from a satellite versus me sticking my little SQM reader out of a window of a moving car. So 20.93, 20.3, 20.09, 19.82. Now the difference is only about, I think, 2 years between this data and the data that I got when I was running around in my car. And obviously things will be different night to night, depending on transparency and stuff like that. 19.58. I don't think that in 2 years it could have gotten that much worse. Alright, so now I have the latitude and longitude in a single column, and now I'm going to make a chart. So that's interesting. It seems like the map SQM is always higher, and the difference is not always the same. So that could have been anything. That could have been just how I had the SQM reader pointed. When I was driving down the road, I would kind of just point it out the window and straight up. I don't know how that would affect it, considering I'm on the road and there's headlights and brake lights and stuff like that. That said, it was like 3:30 in the morning, so there weren't a ton of people out there. That said, I'm not quite sure where this difference is coming from, but it does seem to be pretty real. Alright, well, after looking at the Bortle scale on Wikipedia, it looks like that should be about correct. So from the looks of things, it is pretty substantial, the difference that this actually has. Like, here we've got a single point. I mean, that could have been anything. That could have been like a street light nearby. So maybe this one I'll throw out. But it's still looking like the map SQM is a little higher. It could be because of what I was saying before with how the satellite that's taking these images is only looking at the ground brightness rather than like the total sky brightness. So that could be the reason for why it is so different. But that is still quite a difference. I think there might just be a fundamental kind of limit to what the little SQM reader can do. Either way, I think it's still a pretty cool tool. You'd probably just have to kind of take that data with a grain of salt. It's not perfect, but it is probably the most realistic reading that you could get. Obviously, because when you're out there and you're taking your data from this SQM reader, you're getting it as the conditions are in that moment. Whereas the SQM from the map might be kind of like the ideal conditions, and also it is only the pure ground brightness rather than the effect that it has on the atmosphere and, with everything combined. So I think that might be part of the reason why this data from the SQM reader itself is a lot different than the map. Whereas if we take a reading around my house, yeah, 19.82.
Alright, so I'm outside my house right now, and I'm seeing stars. There's one. Let's see what the SQM reader says with 2 streetlights nearby. I'm gonna back a little bit away from the house, put it in my shadow, kinda. Let's try that. 19.36. So that is without moving at all and repeatedly hitting it. It's pretty good for pointing it the same way. And if I point it kind of straight off to, I guess, whatever that angle is. I'm trying to keep my voice down because there's people around me on both sides. Let's hit this one more time. I'll give it like 2 seconds. So it looks like it's pretty precise, at least. It's pretty good, I think. And if we go to the back side of my house. Alright, so we're in the back of my house now. The moon's right there. Curious. Let's try putting the moon into my shadow. Ooh, look at that. The only light we have is this one, that, and that guy.
I'd say it's kind of like a similar kind of deviation from as the rest of them. This is quite interesting. I haven't made this comparison before, so I'm actually kind of surprised by how off the SQM reader is. I'm sure that just the local conditions and just the conditions of that night are probably what's to blame for why the map SQM is always reading slightly higher than what my reader was reading. But yeah, this is just a quick comparison I wanted to make, and obviously it seems like we do have quite a bit of a deviation between the SQM reader and the true, or at least the map version of the SQM. So that is interesting. When I go up to my place in Wyoming, it is right around here. If I pull a SQM from here, it's literally saying it's like as dark as can be, and it is, because, you know, the only thing that there is Laramie to the south, but that is quite a distance away. More than 50 kilometers, I'd say. Yeah, like 30, 40 miles away from where Laramie is, which is the brightest light source in that area, other than Rock River, but the center of town's blue, so I doubt that's really going to affect anything. That is quite interesting. I'm actually kind of surprised at how different it is. Now, obviously, that is probably just because it's like a local like thing. Like, those are conditions of the night, and they are similar but not exact. If we go to Unihedron's website, we can take a look at my sky quality meter. I'm trying to take a look at the specifications. I've got a map as well of other people's SQM readings. Alright, let's find one. Okay, so from here, where this this guy, whoever that is, they got an SQM of 21.69. And then if I take these coordinates, punch them in here, I'm getting a reading of 21.95 on the website. So let's do this again. We're getting 21.43 on this map, and then from there reading, they're getting a reading of 21. And the reason I'm staying with Colorado is just because it might have similar conditions, kind of higher elevation, all that stuff. I wouldn't want to compare it down at like sea level, say, because it might be a little different. So yeah, on the map we're getting a reading of 21.97, and over here we're getting a reading of 21.69. It almost seems like the bias is downwards is like 30, like 0.3, 0.4, something like that. Yeah, maybe, you know, up and down a little bit, but there is like a slight decrease from the SQM reader. Alright, so from this spot, we're getting a reading of 20.89, and then they are getting a reading of about 20.60. So that is pretty close as well, again around 30 or 0.30 of a difference, but the SQM reader seems to be reading downwards. Oops. Gosh. Alright, so let's try that. Oh, God. Alright, so let's try this. Bam. Now that's looking pretty similar. So it looks like it's not just my SQM reader, it is all sqm-Ls from Unihedron. Their specifications say the half width, half maximum of the angular sensitivity is about 10 degrees. Full width, half maximum is then around 20 degrees. The sensitivity to a point source 19 degrees off axis is a factor of 10 lower than on axis. A point source around 20 degrees and 40 degrees off axis would register 3 and 5 magnitudes fainter respectively. Let's try to take a look at this. That's very interesting. Very good. So here is the FAQ from Unihedron. Apparently, transparency-wise, the SQM reader is assuming best transparency, which is obviously not always the case, which could explain why the magnitude is lower than the map as well. Okay, here we go. Reading accuracy. The value produced by the sensor in the SQM is affected by temperature. There you go. There's a temperature sensor that compensates for this effect. However, when the SQM is first powered up, the light sensor is colder than when the power has been on for a few seconds. Depending on the ambient temperature, this will result in the first reading being slightly higher than subsequent readings. For the most accurate results, it is best to take many readings and disregard the first reading. That's interesting. So I guess you could just take a bunch and average. That is quite interesting. That said, I was keeping the SQM meter in my car, and you know for a fact I was blasting the heat on my way back, so the sensor should have been at least warm. And according to this, it can go to 23, which is just pure blackness, I'm assuming. And here we are back at the Wikipedia page for Bortle info. I would say that I was in a Bortle 3. Yeah, I would say that this is pretty legit. I mean, it gives you the right kind of like Bortle, I'm assuming. So going off of this, if we move all this stuff out of the way. So it's just about, no. It's quite off, isn't it? Other than like this one, for some reason. The rest are like more than 0.5 off, which is pretty neat. This one's like off by like a whole freaking point. And this is from the darkest place that I've been. and it was definitely super dark. I'm wondering if it just like never gets up to the full darkness level. Like I don't know, it seems like it's just off slightly. So knowing all of this, is it worth it? Is it worth it for this thing? Mine doesn't have a button. So with all of that in mind, is it actually worth it to buy this thing? I would say that it wouldn't really do anything for you in terms of like, actually doing anything useful for your astrophotography. It's just kind of like a way to get a little bit more information about your site or, how your conditions are. And if you're getting creative with it, you could just, put it out every other night or once a week or something like that, and you can kind of monitor how your sky is through the year. It'd be kind of cool to see how that changes over time. That said, if I just go and do this, now, is the sky quality meter actually worth it? I'm gonna say yes, because I own one and I like having it, and I didn't spend all that money for nothing. But at the end of the day, it is not quite the same as what you'd get from the map. It is inaccurate from the map, and you can't do anything with it other than just push the button and you get your number, and that's it. Like some of the other ones from their site, obviously there's a ton of stuff here, but like if we just go for this one because it's the most expensive, that's got all sorts of connections that you could hook it up to your computer, and you could probably leave it running for who knows how long, and have kind of like an updating map or something like that. I would not buy this personally. I don't have a need for that, but it is pretty neat to see it. So like this one is the original, that is 138, and then this one, I'm not sure what the actual difference is other than maybe sensitivity. Unprecedented sensitivity in a handheld meter. That's $155. The next one up, LU, which has a little USB port, you can hook it up to your computer, that is $264 if you want this stuff. And the housing, the PVC pipe with a little hole in it, and some tube rings. That's pretty good. An extra $50. Yeah. Don't know. But I think it's nice having one. I think it's a nice thing to have when you're out. It kind of gives you an idea of what your conditions are in the night. It gives you something to brag about or to cry about. But that said, you can just look it up on a map, and that'll give you, an outdated and not quite the same, result that you would be getting in that time that you're there. But, it's $155. I think this one specifically, the sky quality meter, is just going to be down to whether you are into that sort of thing or not, and if you want like kind of like a fun little accessory for when you're out imaging, and it's something to kind of like hold up to other people if you're showing people stars or whatever, and explaining what it is all about, increasing the general public's knowledge of light pollution, stuff like that. This thing would be a great thing to have and to use. But you can also just get the same information from the light pollution map. So ultimately, if you're only looking for the information, I would say to just not even bother with this and to just use the map. Obviously, with my results, it was like 0.5 of a magnitude, half a magnitude lower than what the map would say it was. But, like that spot in Wyoming I was at, that is incredibly dark up there. And I was shooting, it was galaxy season, it was right around now, so the Milky Way wasn't up. I was pointing the thing up at zenith, and even though the website says it is a 21.9 something SQM, my reader was only getting like 21.6. So, So if you're not into the whole accessory thing, or you don't want to spend $156, $60 or whatever, I would say this thing would only be worth it if you want to really know what, information about your night in that time. You want to show other people what's going on with the sky and all that good stuff. Teach people about light pollution. Ultimately it's going to be up to you whether you think it's worth it or not. Personally, I do enjoy having it. I like being able to, check what my readings are. I like, just playing with it. It's a fun kind of little device. So that was a quick little comparison of the sky quality meter and the sky quality maps that we can access. Obviously, they're not quite the same. You're going to have differences due to just, nightly conditions, even hourly conditions. It'll probably be different. According to them, the sensitivity is pretty good, but they tell you to throw away the first reading that you get. I know for a fact that I would use some from, the first time I click it. I didn't realize that there was a temperature issue with the sensitivity of these things and the results they gave you. But in the end, I do enjoy having it. I think it's a fun little tool, and that's about it. If you'd like one, or you'd like to at least check out what they are and what they're all about, I'll put the link to their website in the description. And yeah, thank you for watching.